Hello, my name is Mika, and this is the second episode in my research vlog self-study series where I explore new advances in deep learning, specifically with focus on 3D generative machine learning and applications in gaming and media space. And today I will just share with you what I did in the last 1.5 weeks since the first video in our series. And also we will dive deep into NeRFs, because a lot of people are very curious about neural radiance fields. So I will try to show you how NeRFs work, and I will explain two, I think, most crucial research papers published in NeRFs. So let's dive in. So this week, obviously I found a lot of new resources that I want to go through, but there are much more resources that I can do in 1 week, so I still need to go through all of this. Other than that, this week I also focused on basics, and I tried to really make sure that I understand diffusion models and new techniques that we found effective in diffusion models, because if I want to use diffusion in 3D, best if I can understand it, how to apply it in 2D and how to get as much of it as we can at this point. And towards that, I went through all different research papers and different resources, and I wanted to share with you resources I found the most useful. So that would be definitely this research tutorial series from Alexa Godrich from the AI Funny channel. So these are 7 episodes. They are kinda connected, but basically all of them are focused on different aspects of diffusion, where Alexa is going through different research vlogs and these different research papers, and in this step-by-step way explain how the research works, what are the new insights that we use to actually get the results. So that was very useful. And it wasn't the first time I watched all of these videos, but it was definitely a good thing to refresh my memory on all of different things that make diffusion work. I just watched it on 2x speed and it's really good. Other thing I found was this tutorial from CVPR 2022 conference. So it's very good tutorial. I think the video and audio quality might have been better, but it's pretty good, and I think very informative. It shows all of different aspects of diffusion and how it relates to GANs and VIEs. And I will share both of these resources in the description of the video on YouTube, so check it out. Other than that, I try to learn more directly about this 3D mesh generation that I talked about in the first video, and these are the research papers that I wanted to go through. Specifically, this one is very interesting because they directly use score-based generative 3D modeling, so basically diffusion, to generate 3D mesh. And the results are not perfect, but this is definitely a direction I'm very excited about, because it allows to generate meshes, it allows to then modify them very easily in typical 3D modeling way. This is very interesting, exciting research, but all of this research is using this marching tetrahedra algorithm, which is kind of a bit different version of marching cubes algorithm, and it's in a way it's based on this deep marching tetrahedra reconstruction representation trained by NVIDIA in 2021. So first I need to go through this research to really understand how this algorithm works. So my goal for the next week is to check through this one, understand it on deeper level, and then be able to fully understand the results from mesh diffusion and also get3D. Get3D is a bit different because it doesn't use diffusion, it uses adversarial training, but it also uses this marching tetrahedra idea. And there is also this paper that I already started reading, but I want to go through in more depth next week, which focuses on conditioning these diffusion models through different means, and specifically using text prompts, edge map, or segmentation maps or other sources like that. And this is, I think, very exciting because we need to be able to control the 3D generation process to actually get value out of it. So I will be definitely reading that this and next week. Other than that, this week I also try to refresh my knowledge on NeRFs, as I said, making sure that I remember everything what is relevant about all the basics, and also update myself on all of the progress that was made in last year on these topics. And one of the disadvantages of NeRFs is that it's hard to edit them because they are encoded into the neural network, and the whole representation is part of the weights of the generator. So we cannot really manipulate them that easily, directly. But there is some new research that actually focuses on this topic. For example, the research from Niantic, which is a company that is currently owned by Snap, which focuses on removing objects from neural irradiance fields with 2D masking. So you can basically create a mask and make the object vanish, which is very interesting. So this shows this application of this new technique to NeRF editing, and I don't know how that works in any degree yet, but this is definitely exciting research. I want to explore more. Or, for example, there is this research on manipulating NeRFs with text using clip. So it's kind of similar to how we manipulate images with clip. Or even using control nets on NeRF to compose scenes together into bigger scenes. So I'm very excited to learn more about this research. I don't know how good it is, but even if it's not best yet, it's interesting research direction, because if we could edit NeRF effectively and we could manipulate them, maybe they are actually better representation than meshes. So it's definitely something I want to explore more. So yeah, so that's it when it comes to my refresher on what I did in the last week, that 1.5 week of my study and research. And I also went through some other less relevant papers, but let's focus on this in the video. And now let's dive into NeRFs and how NeRFs work. So NeRFs were introduced in 2020, and these were the first paper when I think NeRFs methodology was proposed. So NeRF initially was only focused on this new view synthesis task. That is, we have pictures, photos of the scene from different point of views, and then we can sample a new point of view. So let's say the picture is from here, we can sample point of view from here, and using this NeRF we can render this view of the scene that does not exist but was captured by these different pictures from the new point of view. So this can be seen here, right? So probably there in the dataset there is not specific frames of this video, but all of these different videos, all of the different frames in the video were generated with the NeRF. So we see that this has actually really high quality, and compositionally it's very good. So NeRF were instantly very exciting. Unfortunately, they have some limitations that we go over. Some of the limitations were removed later, but still the issue with editing of them, etc. is very problematic. But they are very exciting, especially for reconstruction of the scenes that we can capture with pictures in real world. So it works pretty well. So how the NeRF works basically is that we have a neural network that takes as an input the coordinates in 3D, XYZ, and additionally coordinates of the point of view of the camera. So this is our radial coordinate and azimuth, and basically we can sample the ray that goes into the camera from this coordinate, and from into the camera that is positioned at this particular view. And we can sample this ray that goes into the scene, and we can gather the colors and the density at this particular position. And with that, we can render the picture from that particular frame. So basically, we input these coordinates, we get a color and the density at this particular position. So what is this density? This density basically is kind of like an alpha channel, you can think of it, of the 3D space. So obviously when it's like empty, then alpha is 1, there is absolutely you can see through it, right? But if it's if the alpha is 0, so it's not transparent, there is basically the color. So we use this sigma to denote how much color we can gather from particular point in 3D space for the factual image that we want to render, right? And as we can see, we sample these points in the space, and with that we can render the image starting from this point of view, for example. So actually what we are doing, we are building this representation in the weights of the neural network to represent this particular scene. So the neural network in this case is actually not trained on multiple scenes, or it's not trained to generalize to different objects or scenes, but actually we have one neural network per scene. So in particular, one specific training is needed to generate the multi-view, the ability to generate new views for a particular scene or object. So this is a very big limiting factor. We will see that in practice. But if with that we have very impressive results. So this particular view uses this changing camera direction. We can see that all the reflections that are created in the picture are interpolated from this particular camera view. So these results are very exciting. Then we can obviously transform the NeRF into the mesh using marching cubes algorithm, maybe also using this marching tetrahedra algorithm. Probably that will even result in better quality of the representation, and we will see how that works. Yeah, so let's dive into the paper. Hello everyone, I tried to record a deep dive on the research papers on NeRFs, but it got quite long, so I decided to cut the vlog here, and the NeRF video should be published already, so you can check it out and see the actual deep dive into research papers. And I hope this overview that is in the vlog was interesting, and if you want to learn more, specifically how the NeRFs were built and why it works so well, check out the research paper deep dive video. And if you like the vlog, please subscribe and like this video. Thank you. See you later.